Hi, this is sbodily with IBM. I'm part of the Advanced Technical Skills team located out of Dallas, Texas, and I'm about to perform a demonstration of a failover using dynamic node priority in a PowerHA cluster. So before I actually perform this demonstration, let me actually give an overview of what dynamic node priority is. First of all, dynamic node priority has been in the product for many years. It's actually had three capabilities in the past, which is failover to a given node based on some pre-selected criteria. Now, first and foremost, the most important thing to know is that dynamic node priority does absolutely nothing in a two-node cluster. You must have a 3 or more node cluster for dynamic node priority to be relevant. The idea behind it is to make a decision at the time of failover on who is the most viable candidate node to failover to. So the three that we've had historically is based on free CPU, memory, which was actually paging space, and disk I/O. And in recent years, because of virtualization such as shared CPU pools and memory sharing, etc., it's rare that we actually have the need to use that exact criteria anymore. So actually, starting in version 7, we actually released 2 new user-defined options. And the short story here is you can see them listed at the bottom of this slide, which is the user can specify a script to be run at the time of failure. It'll be run on each node that is a potential failover candidate node, and based on either the highest return or the lowest return, it's looking at the exit return code, will determine who is the best suited node to failover to. So for my demonstration, I've actually put together a very simple scenario. So let me give an overview of my configuration. I do have a 3-node cluster with HA4A considered as the home node, and then I have 4B and 5A as failover candidate nodes. I do have dynamic node priority set. And you can see here that for the dynamic node priority, I've chosen the highest option. So whichever one has the highest return code is where it's going to failover to. You actually specify in the change show resources attributes for a resource group menu these options of the script path and some timeout value. So I have a very simple DNP script that I'm going to show you on the next slide in just a second. Then I have a service IP address, a volume group that I actually have 2 file systems in, and a dummy app server that really all it's doing is running the banner command, but for my demo that's not completely relevant either. This demonstration, you can see that I happen to be running what's mostly the current levels of both PowerHA and AIX of 712 SP1. So here is my DNP script. It's a very simple script that exists on each node in the cluster. Now, technically, I probably don't have to have one on 4A for the demo, but I have it on each system anyway. And you can see for 4B, it has an exit 2, and for 5A, it has an exit 5. Now, it could be a 3, really anything greater than 2. But what I'm trying to demonstrate is that at the time of failure, it's going to fail over to 5A instead of 4B, even though 4B is listed as the next one in the node list. Because I have dynamic node priority enabled with the highest option, it's going to end up failing over to 5A. So I'm going to demonstrate that. First, let me switch over to my PuTTY sessions to show my 3 nodes, and we'll start the demo. Okay, now I have my 3 PuTTY sessions up. I have a terminal window open to each one. On 4A, I'm just showing my DNP script on each node using the distributed command clcmd to verify the contents are the same as what I mentioned in the slide. I have the cluster status monitoring tool called QHA running on node 4B. This shows that currently my resources and resource group is up on 4A. That's normal. It's the original primary node. If I look back on 4A, I can see that the DBVG is active in concurrent mode, which is normal. There's my two DBFS file systems. And here is my service IP address that goes along with it. So the resource group is up on 4A. 5A, the only thing it has is the volume group active in concurrent mode. It's actually in passive mode, which is normal for all failover candidate nodes to have the volume group up in passive mode, as you can see here. But you can see that I don't have the file systems mounted. Just what's considered normal. This is what the daily production environment would look like. So what I'm going to do is I'm actually going to halt 4A with my preferred method of doing a reboot -Q. I like doing that because it gives the same effect as a halt, but then I don't have to go back into the HMC and manually restart the LPAR. So I'm just going to move these windows around because 4A is going to go away. And we can see that our cluster status has now lost connection with 4A, and it's already failed over. Now, the failover was very quick because I don't have a real application for it to run. So this hasn't been time modified. You can view the time, the clock up here. And if I look over on 5A now, I can see that my DBFS file systems are mounted and my service is available. The other thing here is to actually prove in the logs where it made the decision to fail over to, and let me show that. So what we can do is actually check the contents of the clustermanager.debug to see that the DNP sh script is actually being executed and what the return is. Now, since I've already done this before, I know you can do a search on SDMP script exit to see what the return code is. So right before this, you can see that we ran the script successfully. I'll back up for a second here. And you can see here that it's executing the script, dnp.sh. And if we come down a little bit, we get this exit value of 5, and then it sends the results off to be voted on. So if we look at HA4B, we can still do a search on the same thing, the SDNP. Now, if we look over on 4B, we can check the same thing in the clustermanager.debug of the SDNP script exit. And you can see here we've got the value exit return code 2, and then the same thing. It sends the results off for approval, and then there is what's called a voting sequence to determine who is the best suitable candidate, and since number 5 was the highest, then number 5 wins. In our case, happens to match up to HA5A, and that is where the determination is made of which node is to fail over to. So with that, I'm actually going to conclude this demonstration. With this demo or any other demo, or if you have any questions, comments, feedback, suggestions for other demos, Feel free to send me an email. My email address was listed in the opening slide, which is sbodily@us.ibm.com, and thanks for watching.